All right, let's jump right in. Today, we're going to talk about something that's running your body literally every second of every day, completely behind the scenes. It's your body's autopilot, the autonomic nervous system. Okay, I want you to picture this. You've overslept. You are sprinting through the airport, dodging people left and right. Your bag is just slamming against your back. You can see your gate, but they are about to close it. We've all had that kind of heart-pounding, frantic moment, right? So in that exact moment, what is going on inside your body? I mean, your heart is just pounding out of your chest, you can't catch your breath, and suddenly the world seems to snap into super sharp focus. The crazy part is, you're not telling your body to do any of that stuff. It's just happening. So who's pulling the strings? Well, it turns out your body has this incredibly sophisticated autopilot system, and it's designed to take over in exactly these kinds of moments. So if you look here, this is basically the command structure for your entire body. You've got your central nervous system, that's the brain and spinal cord, kind of like the main headquarters. Then you've got the peripheral nervous system, which is all the wiring that connects HQ to, well, everything else. And see that one branch right there? That's what we're talking about today, the autonomic nervous system. You can think of the autonomic nervous system, or ANS, as your body's ultimate backstage manager. Seriously, it's handling all the things you never, ever have to think about. Your heartbeat, breathing, digesting your food, your blood pressure. It is working 24/7, nonstop, making sure the whole show keeps running perfectly without you having to lift a finger. Now, this system basically has two major divisions that are constantly working against each other. First up, let's talk about the emergency response team. I like to think of this as the body's gas pedal. This is what we call the sympathetic nervous system, and its whole purpose in life is to get your body ready for intense action, for stress or an emergency. This right here is the famous fight or flight response that you've heard so much about. So how does it actually do this? Well, it floods your system with a neurotransmitter called norepinephrine, and that basically floors the gas pedal. Suddenly, your heart rate skyrockets to pump blood everywhere, your pupils get wider to let in more light so you can see better, your airways open up so you can suck in more oxygen, and your liver just dumps a ton of sugar into your blood for instant energy. It's also why, when you're sprinting for that plane, the last thing on your mind is that sandwich you ate. The system literally shuts down digestion to save every last bit of energy for the crisis. Okay, but obviously you can't have the gas pedal floored 24/7. You'd burn out, right? And that's where the second division comes into play. If the sympathetic system is the gas pedal, then this next one, well, it's the brake. And this is the parasympathetic nervous system. Its job is the polar opposite. It's all about calming things down, helping the body to, as they say, rest and digest. Its whole focus is on conserving energy and taking care of all the important housekeeping stuff, like recovery and, you guessed it, digestion. It does all this using a totally different neurotransmitter called acetylcholine. This system is what gently applies the brakes. It's what slows your heart rate back down. It constricts your pupils, which is actually really helpful for focusing on things up close, like a book. And of course, it fires up your digestive system to process food and store energy. You know that sleepy, calm feeling you get after a huge Thanksgiving dinner? Yep, that is your parasympathetic system hard at work. So, just to recap, we have a gas pedal for emergencies and a brake pedal for chilling out. But here's the thing. Your body isn't just slamming on the gas and then slamming on the brakes. The real magic is in how these two work together, constantly in opposition to create this incredibly delicate balancing act that keeps everything running just right. And this table here just lays it all out perfectly. It really shows that dynamic tug of war. I mean, look at the heart. One system speeds it up, the other slows it down. The lungs, one opens them up, the other constricts them. The digestive system, one literally hits the pause button while the other hits play. Almost all of our major organs are getting these opposing signals, and it's this constant push and pull that keeps our body in that sweet spot of balance we call homeostasis. Okay, so this whole thing is supposed to be automatic, right? But what if it wasn't? What if we could reach in and intentionally press the gas or tap the brakes ourselves? Well, it turns out that's exactly what a huge part of modern medicine is all about. Hacking this system to help treat all sorts of conditions. So to get how this works, we just need to know two quick terms. First, you have an agonist. An agonist is something that mimics the body's natural signal. Think of it like a master key. It fits in the lock and opens the door. Then you have an antagonist, which does the exact opposite. It blocks the signal. It's like a key that fits in the lock but won't turn, and now no other key can get in. Okay, let's put that into practice. Say we want to hack the gas pedal, the sympathetic system. We could use an agonist, something that mimics it. A perfect example is epinephrine in an EpiPen.
It forces a massive fight-or-flight response to stop a severe allergic reaction. Or think about an asthma inhaler. The albuterol in it mimics the signal that opens up your airways. On the flip side, we can block the gas pedal with an antagonist. That's what beta blockers do. They block the go-go-go signal to the heart, which is why they're so great for lowering high blood pressure or even helping with stage fright.
And guess what? We can do the exact same thing for the brake pedal, the parasympathetic system. We can use an agonist to mimic the rest and digest signal. That's what a drug like pilocarpine does in eye drops for glaucoma. It forces the pupil to constrict. Or, and this is really cool, we can block the brake. A drug called atropine is a classic antagonist for this. It stops the slowdown signal from reaching the heart, which is why it's a lifesaver in an emergency when someone's heart rate is dangerously low.
So you see, this is way more than just some abstract biology lesson. This is the fundamental system of balance that is running your life every single day. It's this constant tug of war between gearing up for a crisis and powering down for calm. And really, understanding this push and pull is the key to understanding not just how your body works, but how we can step in and help it when things get out of whack.
And that brings me to one last thing to think about. Our bodies built this incredible system to deal with, life or death dangers, like running from a predator. But what happens in our world today? A world of nonstop notifications, looming deadlines, and sitting in traffic. In this kind of world, is our fight or flight system just always on? Is our foot basically stuck on the gas? It's definitely something we're thinking about.